Earlier in this episode, I said how it would be very difficult in 60 minutes in an hour-long podcast episode to convey all the things that somebody needs to know in order to optimize their AI system. Your book actually ends with a 175 item optimization checklist, which kind of goes to prove my point that if we took a 60-minute episode, we'd be able to spend 20 seconds on each of those items in the checklist, which obviously, is not going to convey any meaningful information. But if a listener had to take a handful of those, maybe like three of those, as the kinds of optimizations that would give them the best return on their time, investing their time in that, is it easy to kind of say that, these handful are the kinds of key things that they need to be doing?
I'll give you a little tip, which is if you have the PDF of the book, which obviously I do, I give that to Cursor. I give that to Claude Code. And when I'm analyzing a system, right? Because these models don't have all of these things at their fingertips. There's a lack of training data, for example. So one thing I do is I actually put the book in context, and it's 1,000 pages, so you need a big model that has a big context window, and ask it, like, what are the top 10 things I should be looking at? So, and it'll start to run its checks and everything, assuming that you have the right tools installed, which is the NVIDIA Insight and the NVIDIA Compute. So that's kind of longer term what you would do, which is like try to give enough context. Now, I think this will change because I know firsthand that the labs are training more and more on hardware specific for like AMD, because they themselves have this like interest in their models getting better at like optimizing kernels. But to be very systematic about these things, I'm certainly going to talk through a few of these, but make sure there's some sort of like before and after profiling, best practices, things like locking the GPU clocks and making sure it doesn't hit, peak. But then there's really having like a methodical way of, going through. In like my GitHub repo, for example, I've got this harness that will do things consistently before and then after. And if there's any inconsistencies, it'll fail the comparison and say, hey, this is not apples to apples. So it's extremely important that you have like a very, very methodical way of like comparing changes. But yeah, things to keep an eye on. I'll start small and then kind of go bigger. On a single GPU, obviously you like really want to understand if you're on Blackwell, has extremely different characteristics than Hopper, then we'll have, in the future, Vera, or I think it's Rubin, is the next generation, and then Feynman is the next generation after that. But separate from the GPU, there's a lot of things that can go wrong at the actual operating system level. And with the like GPU driver, for example, right? There's the famous CUDA toolkit and then the NVIDIA driver. And yes, anyone that's tried to enter this world has spent, I'm sure, countless hours trying to get these things synced up and the versions all, set up properly. Once you get past that, and I do want to emphasize that you should always be on the latest. I don't always upgrade for the sake of like upgrading in my life, just sort of generally. But I've noticed in the GPU world, it's extremely critical to stay up to date. That does cause problems because sometimes the PyTorch doesn't keep up with the latest CUDA 13.1, but you really, really have to be aware of the versions in this world. But yeah, I would keep an eye on memory fragmentation, extremely important. You want to disable swap, for example. These are things that if you just get a basic Linux system, these things are all turned on because they're optimized for CPUs and just sort of general purpose workloads, and a lot of different, tuning that goes in. this was actually one of my favorite things about the sort of SageMaker um, uh, right, like sort of ecosystem is that there was a lot of work put in. Yeah, so SageMaker is the Amazon or it's a service within AWS that like offers you like GPUs, and specifically there's a service called SageMaker HyperPod, which is like pretty bare bones in a good way. It's got Kubernetes installed. It's got all of these things tuned. You've got a lot of people focusing on this. There's a lot of customers that are tuning, that are helping Amazon with the right configuration for all of these things. You almost always want to occupy the entire GPU. So you don't want to share like you would in a CPU land where you can split it up and virtualize it. You want to get as close to bare metal as possible. Um, Containers have gotten a lot better throughout the years with GPUs. So we're seeing a lot more folks use Kubernetes and Docker for these kind of things. But I would almost encourage to stick with bare metal. I/O optimization, I think, is the number one killer here. This is the lowest hanging fruit. Use the fastest disks that you can get. Use local disk. Don't try to use any network file system. It's convenient to use a network file system, but it will almost always cause you problems. I had said earlier that Jensen, the CEO of NVIDIA, has been focusing a lot on storage recently. Probably not as much as I think he should be going forward, but he does have a lot of partners that are working with, and there's something called GPU direct storage, which can load data from disk right into the GPU without going through CPUs, without creating copy buffers and those kind of things. So that would impact the sort of data pipeline. And when you scale, of course, to multiple nodes, multiple GPUs, which is these days just a given, you really can't do anything that like complex on a single GPU anymore. So then you start to optimize the network, and then you have to make sure that you're using direct GPU to GPU communication, and use things like NVLink, right? The NVIDIA interconnect that's been optimized for the. So one piece of advice is when you're looking around for a GPU cloud provider, I guess these days people call them neo clouds, like CoreWeave and stuff. Try to find one that has bought into the entire reference architecture, like by NVIDIA. If there's a group of I guess cloud incumbents that have their own networking, that have their own stuff that's been built up throughout the years, and they are basically patching and bypassing the sort of natural way that the NVIDIA GPUs were designed. And that's actually, in like my opinion, the highest value proposition for these neo clouds is they're not tied to all of those sort of CPU legacy ways of like doing things. They have bought into the NVIDIA ecosystem. In some senses, they're favored by NVIDIA, I would posit, which seems natural, right? Because you're going to favor customers that buy a lot more from you. Because keep in mind, one of the most pivotal aspects, or the most pivotal like acquisition, like by NVIDIA, was this company Mellanox. So they bought this company Mellanox back in I think 2019. I think it closed in maybe 2020. They're purely networking. And so now, like NVIDIA since 2019 has gone from just a GPU company to an AI systems company. And so if you buy into that whole thing, there's a lot of efficiencies that happen. Even in the network hardware can actually do calculations with these like Mellanox routers that like NVIDIA purchased. So